Welcome back to lesson 4.3, L'Hopital's rule. We're going to be tackling a couple of the more challenging problems from your homework packet today. First of all, we're going to start with example 1, which can be found problem 5 in your packet. It gives us limit as x approaches 1 of 2 times x squared minus 1 over the natural log of x squared. So first step we want to do is we want to plug in that value of x equals 1 everywhere that we have an x, and see if that gets us 0 over 0 or infinity over infinity to test if L'Hopital's rule is even necessary. So we're going to do that. So if you remember your natural log properties, you'll see that natural log of 1 squared, or natural log of 1, is 0. And of course, if you have 1 squared minus 1, or 1 minus 1 times any number, you're going to get 0. So up top, we have a 0. On the bottom, we have a 0. As L'Hopital's rule tells us, that means we have to use L'Hopital's rule, derivative of top, derivative of bottom, to find this limit. So I'm going to pause for a sec. You guys should find the derivative of top, derivative of bottom, and then we'll meet back. So hopefully you found the derivative of top is 2 times 2x, or 4x, and derivative of bottom, natural log of x squared, is 2x over x squared. So, sorry for the noise. So basically, next step, L'Hopital's rule tells us that we can rewrite the function limit as x approaches c with these derivative values. So let's do that. All right, so now we have that. You can simplify it if you want. You don't have to necessarily. Since it is just x equals 1, we're just going to keep it the way it is. So next we have plugging in 1 for x, we get 4 on the top, and then 2 over 1 on the bottom. 2 over 1 is going to be 2. So basically we have 4 over 2, which basic division is going to be 2. So answer to number 5 in your homework packet is going to be 2, because we applied L'Hopital's rule and found that derivative of top over derivative of bottom as x approaches 1 is going to be equal to 2. Awesome. So next problem we're going to tackle, we're going to look at x approaching infinity over when it's e to the 2x times 2x squared, which we can see right here. That's going to be problem 13 in your homework packet. So again, first step, what does it mean for a function to approach for a limit to approach infinity? Basically means that it's going to approach a really, really, really big number, as infinity is a concept that goes on forever. So basically pretend that e to the 2x is approaching a really, really, really big number. If it's approaching a really, really big number, it itself is going to be a really, really big number. So basically, you get infinity on top, 2x squared. That x squared again, if you square a really, really big number, it's going to be a huge number. So again, it's basically going to be infinity on the bottom. So you get infinity over infinity. L'Hopital's rule tells us that if any limit approaches infinity over infinity, then we can rewrite it as limit as x approaches that number of derivative of top, derivative of bottom. So let's do just that. First, like you did before, find the derivatives of the top and the bottom. Alrighty, taking the derivative of top, e to the 2x, you should have gotten 2e to the 2x based on exponent rules of e's. And for derivative of 2x squared, you should have gotten 4x due to the power rule. So next step, as I said before, we're going to rewrite the limit. I'll do it over here. Rewrite the limit as x approaches that same number, which in this case is infinity, of derivative of top, which is 2e to the 2x, over derivative of bottom, which is 4x. So what we'll notice here is that the derivative of 2e, or the limit as x approaches infinity, of 2e to the 2x over 4x will be a really, really big number up here and a slightly smaller number down there. So what we're going to get is an answer of infinity, because it's a bigger number up top than it is down bottom. So it's basically the same as infinity over 1. Let's think about it that way. So that's going to equal infinity. That was number 13 in your homework packet. All right, we're going to do one final problem, example 3, which is equal to 17 in your homework packet. So this problem tells us the limit as x approaches 0 of the square root of 1 plus x minus 1 minus x over 2 all over x squared. So first step, we want to plug in for x. We get x approaches 0, so we want 1 plus 0 minus 1 minus 0 over 2. On the bottom, we have 0 squared. So that will give us, square root of 1 is 1, minus 1 will give us 0, minus 0 over 2, we'll keep that number at 0. 0 squared is going to be 0. So we get 0 over 0. What does that mean? It means we want to use L'Hopital's rule to figure out this problem. So again, take derivative of top, derivative of bottom. Let's do that. We'll meet back, and I'll tell you what to do next. All right, so hopefully you got derivative numerator to be 1 over 2 square 1 plus x minus 1/2. And then hopefully you got derivative of denominator to be 2x. So L'Hopital's rule, let's plug that in. We get the limit as x approaches 0 of numerator over denominator. And then we want to plug in for that 0 value. We get 1 over 2 times the square root of 1, which is 1, minus 1/2 over 2x, or 2 times 0. So that again is going to give us 0 over 0. So what do we do now? We got to use L'Hopital's rule again. Even if you use it once, you can still use it twice. So let's do that now. Take derivative of numerator and denominator, and then we'll meet back. All right, so as x approaches 0, hopefully you got derivative to be of the numerator to be negative 1/4 square root of 1 plus x cubed. Hopefully you got derivative of denominator to be 2. So let's use L'Hopital's rule to plug that in as a limit as x approaches 0. So limit as x approaches 0 of derivative of numerator So numerator, derivative of numerator over derivative of denominator. And then let's plug in for that 0 value. We get 1 over 4 times the square root of 1 plus 0 cubed, or square root of 1, all over 2. So that's 1 over 4 times the square root of 1, or 1 over 2. So let's rewrite that quickly. We get 1/4 times 1 all over 2, or 1/4 divided by 2. 1/4 divided by 2 is 1/8. So that's your answer. Awesome. That was L'Hopital's rule. Thank you and have a good day.